extraterrestrials are as curious about us as we are about them. On a Pacific island, a Polynesian girl is spellbound by a strange sight. "3,000 miles away in Texas, scientists are also making contact with this mysterious life form.
Dark,
Tentacles come out.
Look at the ventral plate. Isn't that neat?
Oh, yeah.
It almost looks hydrodynamic. It doesn't seem real. Gee, that's unbelievable.
Just hovering like a spaceship. It has perfect neutral density. Beautiful. Look at that passing cloud. Fabulous.
These unusual beings are capable of the most staggering feats of color change. But what do these pulsing patterns mean? Are these creatures signaling to one another? Are they perhaps trying to communicate with our world? The search to discover their hidden secrets is only beginning. This is the story of our quest to understand them. Catching a glimpse of the aliens is not easy. But the smoke screen they throw up to cover their activities is starting to clear away. Our knowledge is coming out of the dark. These remarkable animals are cuttlefish. Incredibly, they're relatives of the lowly slugs and winkles, but they are the concords of the snail family. In captivity, they quickly become friendly with humans. They can be tamed and will readily come to hand to be fed, hitting the target every time with deadly precision. The high-speed tentacle strike is so accurate that they can normally discriminate between fingers and food. But a finger on its own proves an irresistible attraction to these playful and inquisitive animals. Cuttlefish, like their relatives, the squids and octopuses, are cephalopods, the most advanced soft-bodied animals on planet Earth. Their natural domain is the inner space of the oceans. But here, at Waikiki Aquarium in Hawaii, close encounters of this kind are on public display. The cuttlefish are the star attraction, and their seemingly friendly antics delight thousands of visitors.
Colors in this one over here. It's pretty.
The way those fins undulate, that is really beautiful.
Yeah, it's like a hovercraft, sort of floating there.
They have a well-developed brain and a high intelligence, measured even by vertebrate standards. At times, a brilliant kaleidoscope of color patterns radiates across their bodies.
Spaceship.
But the patterns, look at the colors on, look at that one right over there.
Oh, that's fantastic.
The patterns just kind of flashing back and forth.
It just looks like a completely different animal all the time.
Well, I don't see how they do all that. It looks like neon or...
Scientists believe these signals form the basis of a visual language whose messages we are only beginning to interpret. Until very recently, this species, with its marvelous displays and masquerades, was virtually unknown. They're not native to Hawaii, and the few divers who've observed them in the wild had to travel to the remote jungle-covered rock islands of Palau in Micronesia, 4,000 miles to the west. Spectacular coral reefs fringe these lonely tropical islands. In these clear waters, on an afternoon in the summer of 1982, divers spotted a majestic cuttlefish cruising purposefully over the reef, like some multicolored submarine. Intrigued by this strange apparition and curious about its behavior, they followed in its wake. Unperturbed by the presence of the cameraman, the cuttlefish began to lay eggs, using her arms to transfer them delicately out of sight to crevices in the coral. Identified as Sepia latimanus, so rarely seen it has no common name, she belonged to the largest cuttlefish species, capable of growing several feet in length. Her sons and daughters were to become the first of their race to be successfully raised in captivity. Some of the hundreds of eggs laid were collected and taken to the aquarium, where, from the first day of hatching, they were encouraged to establish an intimate familiarity with humans. Overcoming our distorted view of the cephalopod world is the aim of researchers at Galveston, Texas. They keep a close watch on all the animals in their laboratory. Long before our discovery of jet engines, cephalopods were jetting through the seas, propelled by water forced through a funnel on the undersurface of their body. Octopuses are reared here also. A sophisticated life support system of tanks and plastic shelters provides them with all the comforts of home. Out of water, the octopus body sags like a deflated balloon. The 8 supple tentacles which radiate from the head are virtually pure muscle tissue and can exert tremendous strength. Their unyielding grip makes it very difficult to prise the suckers free. Each arm is covered in several hundred of the sensitive suckers, which are not only used for holding on, but also provide chemical and tactile information about the surroundings. There is little delicacy in the mating embrace of the octopus. Here, 2 males compete for 1 female in an extraordinary wrestling match. Just who is doing what seems impossible to judge amidst the writhing tangle of arms. Eventually, a partnership is formed, and the male, on the right, will pass his sperm into the female using a modified arm called the hectocotylus. In the laboratory, plastic pipes prove perfect sites for attaching egg clusters, and octopus mothers take their maternal duties seriously. The eggs are constantly guarded, cradled, and caressed to clean and aerate them, exactly as they would be in the wild. Even here, tiny hatchlings live in a competitive, watery jungle. Several kinds of octopus are cultured in Galveston, and not all make good neighbours, content to remain quietly curled up at home. These are experts at breaking and entering. Octopus annoyance can express itself in a dance of frustration, but the only sure way to avoid eviction is to close firmly the door on intruders. In the wild, octopuses build their lairs in empty shells or in the rocky recesses of reefs. This artificial seafloor allows scientists to study in detail their extraordinary skills in manipulating objects. With no joints to hinder movement, the tentacles can bend anywhere along their length. Each sucker can even move on its own. Feeding time reveals the glutton in the octopus. As many as a dozen crabs in succession may be drawn into the web formed by the arms. With the prey pinioned in a lethal stranglehold, the octopus delivers its coup de grace. Using its hidden beak to pierce the crab shell, it injects a fast-acting nerve poison which paralyzes its victim. After a few convulsive tremors, the crab is dead. A digestive enzyme is injected to liquefy its tissues, which are absorbed by the octopus. At the end of a meal, a perfect disarticulated crab skeleton is all that remains. Those who work with octopuses are constantly amazed by them. A major problem facing the researcher is how to thwart their incredible ingenuity in finding ways of escape. The octopus is the Houdini of the sea, but even that great escapologist would have been amazed by its contortions as it squeezes through the tightest of spaces. Keeping octopuses in their tanks may be difficult. The opposite is true of another cephalopod, the cepiolid. This delightful creature actually prefers being enclosed, burying itself on the bottom wherever possible. When almost covered, their long tentacles snake out, adding the finishing touches to their camouflage. Patches of colour on their adhesive skin help to complete the deception. Only a passing shrimp will tempt them out. The diminutive bay squid lives in brackish waters just offshore from the Galveston laboratory. Squids are the most numerous and ferocious cephalopods. They vary in size from finger-length specimens like these to the mighty giant squid, which exceeds 17 meters in length and can engage sperm whales in battle. Squid tentacles are perhaps the most specialized grasping organs in nature, allowing them to overpower and hold on to struggling, slippery prey almost as large as themselves. Highly social, schooling creatures, squid have superb eyesight and communicate with one another using combinations of arm postures and patterns of colored spots, streaks and splotches. These displays and pulsating colors form the grammar of the squid's visual language. It's this behavior which particularly fascinates the Galveston scientists. To learn that mysterious language fluently, they need a regular and reliable supply of animals. These are collected at night on the calm waters of the Gulf of Mexico, where the squid are attracted to bright lights on the surface. Back in the laboratory, work goes on through the night on the freshly caught squid. Roger Hanlon uses lightly anesthetized animals to examine the bursts of color on the skin surface. Even a sleepy squid needs careful handling. The parrot-like beak can deliver a nasty bite. But it's the brain behind the bite that is most intriguing to scientists like Hanlon.
The skin of the cephalopods is a perfect two-dimensional view of the brain. What you have are nerves coming out of the chromatophore lobes, and when innervation takes place, you get something on the skin that says, there's nervous activity. So in fact, what you have in a pattern is a window into the brain.
The color comes from tiny round cells called chromatophores. Each one is an elastic sac containing colored pigment which can expand or contract under nervous control. The mechanism is unique in nature and the rapidity of change is incredibly fast. Underlying iridescent cells add color by reflecting ambient light like minute mirrors. It's the nervous control which allows the kaleidoscope of colors to sweep over the body like some animated neon sign. In squid, this magical signaling system first begins to stir in their egg clusters laid on the sea floor. Early embryonic stages show no sign of chromatophore activity. Only as the nervous system develops do they begin to display their first decorative spots of living jewelry. When they hatch, they have a juvenile coat of scattered polka dots, an adequate enough vocabulary for squid baby talk. By adulthood, the patterns become very elaborate, and mature squid may be capable of transmitting many different messages at the same time to several other individuals, a feat which would tax our ingenuity. But as Hanlon cautions,
the truth is we're only beginning to understand the range of complexity of the patterns, and we're even farther yet from understanding what they mean and how they're used. The patterns are simply too complicated to describe in a cephalopod. They change rapidly, they grade one into the other, and it's simply too complex for the human mind to comprehend what one pattern is. We're looking at videotape recordings of the skin of Loligoplei. This is taken at a magnification of 12 times their original size. You can see small dots expanding into large bursts of color, and each one of these is a chromatophore. So the combinations of colors that you can get are nearly infinite simply by using 3 colors in different grades of expansion and also getting overlap among them. Some of these visual displays are very dramatic. For example, the passing cloud pattern that it's found in octopuses and in cuttlefishes. In this situation, there are waves of color passing from the rear of the animal to the front of the animal just over a period of seconds. The function of these patterns are, number 1, to mesmerize prey, and number 2, to confuse a predator just for an instant in order to escape. Many times when a small cuttlefish will approach a small shrimp near the bottom and the shrimp is turned directly towards it, the cuttlefish will raise several of its arms and this passing cloud will move right across its body, looking totally unlike anything that shrimp has ever seen, and will mesmerize it just for a second. During that instant, the tentacles will shoot out and seize the shrimp.
not every attack is accompanied by rolling waves of color. They also contort their arms and bristle their skin. The result is a creature of fearsome appearance. Unbelievable though it may seem, cephalopods are color-blind. For them, it is not color, but the boldness and brightness of their patterns which are important in communication. But their enemies, like the Murray eel, do have excellent color vision. Cephalopod colors may have evolved to allow them to blend with different backgrounds and avoid detection by predators. Other flamboyant reef dwellers, like the anemone fish, are stuck with a permanent color scheme. So is the mandarin fish. Only the cuttlefishes and their kin have a wardrobe for every occasion. Large crabs are formidable foes, and paralyzing venom must be injected quickly to avoid damage from their sharp pincers. partially hidden crab refuses to budge. Even the hungriest cuttlefish eventually has to switch off and look elsewhere. It's hard to imagine an alien being with the strangeness and variety of these entrancing animals. Perhaps we need go no further than the depths of inner space in the oceans around us to get an idea of what life might be like on another planet.
The ocean is a dangerous place. Just staying alive is the vital mission for these creatures. The giant cuttlefish has a full kit of impressive gadgets, including a unique propulsive system, keen eyesight, and skin that can encode cryptic messages. This animal is a spy master. His eyes even have special filters to increase his powers of surveillance. And he's a master of disguise who can even change shape when necessary. Add to that a formidable brain, and his quarry will be utterly deceived. When all intelligence is gathered, he prepares to strike with a concealed weapon. This animal is licensed to kill. These special agents are the product of 500 million years of evolution in nature's laboratory. Their humble snail-like ancestors evolved into many forms, but they all share the same blueprint. They operate under the codename cephalopods, or to those in the know, squid, octopus, cuttlefish, and the nautilus. These are animals from nature's special branch, bristling with gadgets. But while we invent gadgets for fun, they develop them for survival. In cephalopods, multiple arms with stick-fast suckers come as standard issue. They're a marvel of design. The octopus arm has no bones, but it does have a complex system of muscles, so it can twist and bend in any direction. A soft body is much more versatile than one with a rigid skeleton. It allows an octopus to squeeze through the smallest of holes, a good thing when escaping enemies or chasing prey. To help them grip, each arm has hundreds of suckers. Each sucker has a hole that connects to a muscular bag of water. By squeezing it, they create suction. The sucker rim is flexible and covered in mucus, so it can create a firm seal even on the roughest surface. An octopus has 50 million nerves in each arm. Together, all the arms have twice as many nerves as the brain. This allows each arm to work independently and automatically, especially when the octopus is focused on other matters. This crab's sharp pincers are still no match for an armful of octopus. Mission accomplished. The cephalopod arm also comes in handy during amorous encounters. In squid, the male employs a special packet of sperm called a spermatophore that he will place onto the female when he gets the right opportunity. In Australian reef squid, it's a maneuver that requires him to flip upside down to position the sperm on the female's head. One arm steadies, while the other quickly grabs the sperm packet and dabs it onto the female. Once attached, the female can take the sperm at will to fertilize her eggs as she lays them. Having a specially designed mating arm is a marvel of natural engineering, but one octopus, the ocean-going Argonaut, wins first prize for ingenuity. On locating a female, he detaches his entire mating arm into the water. This severed appendage, full of sperm, moves with resolve towards the female. When it reaches its target, it attaches to her gill cavity, ready at last for active service. Nothing better illustrates how a cephalopod arm can have a mind of its own. The most startling equipment in the cephalopod kit lies in their skin. These are Humboldt squid. At 2 meters, they're the largest squid to be filmed alive. They communicate by flashes of their entire bodies. This secret code is still an enigma to us, but the key appears to be in the frequency of their flashing. Sometimes they pulse in unison, but more often they flash with different rhythms. Perhaps they're trying to work out which agent is dominant. Giant cuttlefish use color to communicate, especially the males, as they battle for mates. They show their level of aggression through skin colors. These cephalopod agents have excellent vision, perhaps better in some ways than our own. Their eyes have polarizing lenses, which act like sunglasses to cut through underwater glare. The signals in their skin are made with millions of tiny colored dots called chromatophores. Each dot is a bag of pigment enclosed by muscles that can make it appear and disappear in the blink of an eye. Chromatophores can work in teams to produce waves and spirals of color. The cephalopod code book hasn't yet been fully cracked, but some transmissions have been intercepted and interpreted. We know that mesmerizing displays like this can distract their prey, long enough for the cuttlefish to strike a fatal blow. This is a secret weapon that really confuses fish. Having talking skin is not enough. It also requires a certain etiquette and body posture. When aroused, the male's arms display bold chevrons. Under normal circumstances, they're hidden. But he quickly deploys them on close encounters with rivals. Displays like this allow males to size each other up without the need for a fight. It's a cephalopod Cold War. This feisty blonde is the cause of their dispute. Or is she a brunette? To remain discreet, she can merge with the background. Or she can lure in the more brightly dressed males with her spotty highlights. In these animals, beauty really is only skin deep. He must give the performance of a lifetime to keep her. This dominant male will spend much of his time on patrol, blocking the advances of other incoming suitors, and displaying to show them who is boss. But even a top agent can't be everywhere at once. Our male is fortunate, however, that the colour code of rival males is easy to spot, and he's ready for them. While the two males fight it out with their full body displays, the female, behind them, waits patiently. Sometimes the dominant male has to devote all his time to chasing away his rivals. But this male doesn't know that there's a double agent in his midst. One who has gone undercover, using female colours to sneak behind him. Once he reaches the female, he turns on the male charm and steals the reward. By the time the top suitor returns, it's too late. The female lays her egg packet inside the protective head of coral. But who is the father? Agent 007 or 008? Cephalopod agents have another use for their colourful skin cells beyond the sexual politics of attraction and deception, and that's camouflage. Not only can they change their colours at will, their soft bodies allow them to change their shape too, with infinite possibilities. Blending in perfectly with the background is astonishing enough, but these animals can also pretend there's something completely different. They're masters of disguise. With the right moves, they can take on the characteristics of other creatures, like a venomous sea snake, for instance, or perhaps a dangerous lionfish. But what does this agent look like? Dead leaves often drift by in the shadows, but who would have thought that this piece of foliage is in fact a cuttlefish? Sometimes the most successful agents are the ones who are never noticed. Cephalopods also have perfect control of their movement. They have another very special adaptation, a jet engine. Of all their gadgets, this is the one that human engineers have most admired. They're very tricky to design and control. But our special agents perfected it 500 million years ago. They're the best jet pilots in the animal kingdom. A jet engine blasts air through it to create thrust. The Cephalopod jetpack uses water. The water is pushed through a special funnel called the siphon, which can be bent into any position. So this cuttlefish can move in any direction with ease. And for fine control, the siphon can be made larger or smaller to change the thrust. But how exactly does it produce the thrust? First, water is sucked through a gap behind the head and into a large muscular bag called the mantle cavity. Next, the mantle cavity squeezes shut and pushes the water out through the siphon. This water jet is powerful enough to propel even the largest octopus. The squid have streamlined their bodies for speed and can jet away from danger in an instant. This jet-set lifestyle may also be used to hunt. The bobtail squid can sandblast the seabed to uncover hidden prey. Others know how to vanish in an instant. By blowing water into sand, they can disappear in a flourish of quicksand. There's one problem with jet propulsion. It requires lots of energy. So some of our jet setters have a way to save fuel with built-in flotation devices. These nautical navigators have evolved several cunning gadgets as buoyancy aids. The best known is the cuttlebone, an internal float. Cut in half, the cuttlebone reveals its secrets. It has a honeycomb structure made up of hundreds of gas-filled cavities. It's a design classic that imitates the Nautilus, one of the veteran agents of the clan. Nautiluses hang perfectly in the water by balancing the amount of water and gas in their internal chambers. It may be slow, but this submariner has such a good design that it hasn't changed for millions of years. Squids, on the other hand, have done away with flotation devices in favor of life in the fast lane. The agile bobtail squid can fly like a bumblebee above the seabed, but when its fins stop flapping, it sinks. And this pygmy squid has an innovative way to stay afloat. It sticks itself to a plant. It does this with its own ingenious superglue. From here, it can ambush passing shrimps. The glue is made by sticky mucus cells that lie along the top of its back, and it also has a solvent that can dissolve the glue instantly when it needs to escape in a hurry. When squid and cuttlefish hunt, they employ the smartest gadgets of their entire arsenal, the feeding tentacles. They can be shot out like party whistles. Feeding tentacles are normally hidden inside the body cavity, like secret weapons. When they fire, they're as fast and deadly as a wire-guided missile. These pictures reveal for the first time how the two clubs at the end of the tentacles open out to lasso the prey at phenomenal speed. It's all over in 1/100th of a second. The clubs have powerful suction pads that stick to their prey like glue. When they've hit their target, the tentacles are rolled up, pulling the prey straight back into the mouth. Once inside the mouth, the unfortunate victim meets a very sharp tool, the beak. This cephalopod can opener is as strong as a set of bolt cutters. It can cut through the shell of a crab and the backbone of a fish. But what happens when the hunter becomes a hunted? Time for an extraordinary maneuver, the release of ink bombs to startle and confuse their enemies. Some ink bombs can hold a shape, which predators might mistake for the intended victim. They also tear gas the entire area, as this cloud contains a chemical irritant. So how exactly do they do this? The ink gland lies in a sac inside the rear of the body. Blobs of ink are squirted out through the siphon. The ink can be made stickier by being mixed with mucus. The direction of the squirt and its shape are controlled by the siphon. The stronger the squirt, the greater the explosion. This ability to respond in different ways to threats gives our agents an important advantage, because in this ocean battleground, you only live once. So, standard issue kit for our cephalopod agent includes color-changed skin, jetpacks, and ink bombs. There are also several chemical upgrades available, depending on the field of operation. Blue-ringed octopuses carry the deadliest poison. There are several different species, but they all advertise their venom using unmistakably bright-colored rings to signal their deadliness. This is the octopussy of Bond fame. A bite from this creature could kill a man in just 2 hours by paralyzing the heart and lungs. This agent has a partner to produce its poison, special bacteria that live in its saliva. In return for food and shelter, the bacteria provide the octopus with the ultimate defense. The bacteria are passed on to the next generation through the eggs. So every octopussy agent is deadly from the start. Another group of youngsters use bacteria in an altogether different way. The young bobtail squid can harvest bacteria from the sea to make light. This squid has a strange horn-shaped organ found in the rear of its body. From all the billions of minute creatures in seawater, bobtail squid are able to select just one single species of light-producing bacteria. The bacteria travel down a tube into a central grow bag. Once inside, the bacteria are fed sugars and multiply to give off light. The gadget even has eyelid flaps to adjust the brightness. Subtle light control is crucial to its mission, especially on bright moonlit nights when it's more likely to be caught. The bobtail squid likes to feed at night, but so do many of its sharp-eyed predators. With its bacteria-fueled headlamp, the squid can switch on the light like a cloaking device to match the background, and it becomes invisible to its enemies. It's as if they've mixed together two organs to produce a new one. The light organ is like a modified ink sac, and the light is projected through an eye-like lens. Another way to produce light is by mixing chemicals together, and that is exactly what the firefly squid does. The surface of its skin has special light-producing cells called photophores. It has two types, little ones all over its body, and big headlamps at the end of its front arms. Nobody has yet deciphered these light signals. Perhaps they attract mates in the dark, or help the shoal of squid to stay together. The squid's light cells are easy to see. They're the blue dots scattered across its skin. The light is created the same way as in fireflies and glowworms. Our cephalopod agents are true survivors. Their secret has been the ability to mold their soft bodies into a kaleidoscope of shapes, colors, and uniquely specialized body parts. The sea has been their mother of invention. They have conquered every marine habitat, from the open ocean to shallow coastal waters, from the tropics to the poles. Weight for weight, there are more squid in the sea than fish. Nothing proves this better than the mass annual spawning of millions of opalescent squid off the coast of California. This, then, is their most crucial mission, to pass their genes into the next generation. And even now, during mating, those gadgets still come into play. Once a male finds a mate, he signals possession by turning the front of his arms red. The male will hold onto his female until the eggs are laid and fertilized, and then they both will die. Other creatures will make a meal of the squid's success, but many of the eggs will survive. But all is not lost. They have succeeded. The eggs will hatch in a few weeks' time, triggered by their own egg timers to be released under the safe cover of darkness. These eggs are proof of a mission accomplished. Inside each one lies the blueprint for the next generation of cephalopod agents.